Hello, everyone. I'm Captain AJ Watson. This is Anacostia Maritime. Today, we're working on Azimuth problem 50332. We'll use Pub 229, Volume 2, as well as the Nautical Almanac and Bowditch. Let's get to it. On 26 February, your vessel's 1615 zone time DR position is latitude 25 degrees, 14 minutes south, longitude 57 degrees, 22 minutes west, when an azimuth of the sun is observed. The chronometer time of the site is 8 hours, 13 minutes, 19 seconds. And the sun is bearing 266 degrees per standard magnetic compass. The chronometer error is 1 minute, 46 seconds slow, and the variation in the area is 6 degrees east. What is the deviation of the standard compass? First thing first, we read our problem. I see that we're looking for an azimuth. I lay out my problem the exact same way every time. It's about the repetitions, all right? Anything you do over and over and over, you're going to get better at. Eventually, you're going to get faster at because you become more precise. So it's the little things that matter, right? Work on the technique, and that is the layout of your problem, okay? I don't care how you learn how to do a problem. Lay it out the same way every single time. Then it becomes muscle memory. And once that happens, you can basically just close your eyes and fall asleep, and your hand is right for you. All right, let's go. ZT, ZD, GMT, CT, CE, true GMT, GHA, minutes and seconds, true GHA. Plus east minus west, all right? LHA. Latitude, longitude, bearing. In this instance, we have the sun, okay? Variation, declination, D number, D correction, true declination. And the three things you need to enter Pub 229 are the latitude, the declination, and the LHA. So I lay my problem like this, and then I write down what is given to me. So in this instance, what we have given to us, we have the date, we have the zone time, we have the DR position, Latin long, huh? We have the bearing, and that's per standard magnetic compass. So that's PSC. We have the chronometer time, and we have the chronometer error, and we have the variation. All right, so we're going to write down what's given to us, okay? (16, 15, 26 February, okay? We have the latitude was 25 degrees, 14 minutes south, okay? Longitude is 57 degrees, 22 minutes west. The bearing is 266. PSC, and the variation is 6 degrees east, all right? That is what's given to us, okay? Hope you guys can see it. Working on my layout, okay? All right. So first thing first, they gave us our chronometer time. All right. And they said 8 hours, 13 minutes, 19 seconds. Okay. But how do we know if it is 2000, which is 8 at night, or 0800, which is 8 in the morning? Okay. In order to figure that out, we need to utilize our longitude and figure out our zone description in order to get our GMT. All right. Let's go to Bowditch, which is the easiest way. And the Bowditch I use is 1981 Bowditch Volume 2. That's my baby right there. It is page 370 that I'm looking for, all right? So scroll with me or flip your pages, however you do it. Table 36. This is in 1981 Bowditch, all right? Time zones, zone descriptions. Where does my longitude fall in line at? 57 degrees west. I see 52.5 degrees west to 67.5 degrees west. So +4 zone description. All right. Let's go over here and put +4. That would then give me 20 hours. All right. So now I can utilize my minutes from my chronometer time, which is 13 minutes. Okay. 19 seconds. All right. Another way to get your zone description is taking your longitude and dividing it by 15. That might be faster for some of you guys. I mean, I'm treating this as a beginner class. So I'll take my calculator, and the first thing first, I want to get my minutes to degrees, to whole degrees, and then I'm going to divide my total longitude, which is degrees longitude, right? And divide that by 15, all right? So 22 minutes divided by 60, all right? So I'm taking my minutes, and I'm going to divide it by 60 minutes in order to equal hours, all right? Or degrees, okay? 1 minute of latitude or longitude, all right, is equal to 1 mile, all right? 60 minutes of latitude is equal to 1 degree. So 0.36666 and then 7 at the end, all right? Now I'm going to add my whole number, which is 57 degrees, all right? So 57.36666, all right, sevens. That is my longitude. This is my longitude right here. Right now, I'm just going to divide this whole thing by 15, and I have 3.8, okay? And this is pretty simple also. If it's over zero point 0.5, so like 3.5 or above, it's going to go to the next whole number, all right? If it was 3.4, it would round down, okay? And us being on the west, it's going to be plus, all right? I like going about it. It's just faster and it's simple. All right, let's continue on. And that was 26 Feb. Sorry, I almost skipped a step. All right, so I get my zone description here. I get my GMT. That's going to be 2015, right? That's just basically trying to get you in the vicinity of where you're at. That's all. Because the chronometer is on your arm. That's your wristwatch that you got on your arm. All right, chronometer error is 1 minute, 46 seconds slow. And slow means add, all right? Fast means subtract. Okay, 19 seconds plus 46 seconds. 19 plus 46 equals 65. And like I told you guys before in the last video, once you go over 60 minutes, you're going to subtract that 60, okay? And that's going to get carried over into the minutes column, all right? So in this instance, we have 65 seconds, okay? 60 seconds is equal to 1 minute. So you're going to carry that 1 minute over, all right? And you're going to subtract the 60 because that's the 1 minute, all right? That's going to leave you with 5 minutes or 5 seconds left. And then you're going to carry that 1 minute over. So this will be 0.5 seconds, right? You're going to carry the 1 minute over. And this is going to be 13 minutes plus 1 minute plus 1 minute, okay? 13 plus 1 plus 1, all right? And I'm going to use my calculator still, okay? 13 plus 1 plus 1. Get in the habit of using your calculator, all right? And check and double check and triple check, all right? So 20 hours, 15 minutes, 5 seconds, 26 February. There was no date change, all right? I know my handwriting is getting out of hand right now. I apologize. I'll get better on the as these videos progress, all right? Okay, now I'm going to go into my Nautical Almanac and get my GHA. All right, the Nautical Almanac we use is the Training Nautical Almanac 1981. All righty. So we're going to go and scroll the daily pages and come on. All right, we're going to scroll the daily pages and we're going to go to our date. And what is our date? The 26th of February. 26th of February. And you see that right there? We're not looking for this page because there's no sun on this page. We're looking for the next one. Okay. So let me get this. Got my highlighter. Okay, February. We have the sun, right? We have the GHA column and the declination column up there, right? Let me scroll in for you guys. Now, let me scroll down to our date, the 26th of February. All right, and our GMT was what? 20 hours, 15 minutes, 5 seconds. So I'm looking for 20 hours. And then we're going to also get our declination from this column here. This column here is the declination, okay? It is. And you're asking, damn, where's the whole number? This is the whole number, okay? If you don't see anything in between these here, it carries down, okay? It just continues down. So, like for instance, up here, you have south 9 degrees, 6.5 seconds. And as you can see, it's going down. All right, this is lessening, okay? See that right there? It's going down, all right? That's going to tell us something in a second. We get our declination, which is south 8 degrees, 31 minutes, all right? So I'm going to write that down. South 8 degrees, 31 minutes, okay? And our GHA is 116 degrees, 47 seconds. 47 minutes. 116 and 47 minutes. 116, 47 minutes, all right? Now, we need our D number. We would get our D number from here, 0.9. And with our D number, we need to figure out if we're going to add the correction or subtract the correction, all right? The way we know it is if this column here is increasing or decreasing in value, all right? And we just said earlier, it is decreasing. It's going down. See 9 degrees south, then you have 8 degrees south, all right? You see that? So that's an easy tell right there, all right? Sometimes you have to look at the minutes because it's all the same degree. So you have to look at the minutes there and be like, oh, okay, it's going down. All right. So D number is 0.9, and we notice decreasing, so it's going to be a minus correction, okay? 0.9, all right? So that's easy right there. Now we go back into the Nautical Almanac, and we need to go scroll or flip your pages to the end of the book where you have the increments and corrections. Increments and corrections, okay? And we're looking for 15 minutes, 5 seconds. That's from our GMT, okay? 15 minutes. Okay, 15 minutes is here. All right, 15 minutes. We have the sun and planets column because that's what we're doing. And then we have 5 seconds. Let me zoom in here. 5 seconds. Okay. We're going to get our D number right. This is our D number right here, right? D number right here. And our correction column here. So D number was 0.9. So our correction is going to be 0.2. All right, so these two things I need from here. The GHA, let's see, minutes and seconds is 3 degrees, 46.3 minutes. And we had 0.2, okay, for our correction. Now I'm just going to do regular arithmetic. Let's get my calculator. It's easy. 31 minus 0.2. 31 minutes minus 0.2, 30.8. So south 8 degrees, 30.8 minutes. That's my declination. All right. And this column right here, or this area right here, is always added, okay? Let's see, 47 minutes plus 46.3 minutes. 47 minutes plus 46.3. All right, we had 93.3 minutes. We're over 60, so we have to minus 60, okay? All right, that's gonna give us a minute to carry over, and we're left with 33.3 minutes. 33.3 minutes. All right, we're gonna carry a whole degree over. All right, these are minutes we're dealing with here. All right, so we had 93 minutes. We took 60 minutes away from it, and we carried over 1 whole degree. 60 minutes equals 1 degree, okay? All right, so I have 1 degree plus 116 degrees plus 3 degrees. 1 degree plus 3 degrees plus 116. That is 120 degrees. All right, and a lot of times people forget this, man. Like, I did it so many times. Like, it's going to take you forgetting this to add this one or subtract this or whatever in order to actually get it, because you need to make these mistakes. You need to make them now, especially while you're test prepping or you're learning, because when it's time to do the test, you're not going to make these mistakes. Why? Because you done prepped. You done had the reps. All right, so let's erase that part. Okay. All righty, now my longitude is west, so I'm going to circle here. That's a minus, all right? My longitude is 57 degrees, 22 minutes west, all right? Subtracting that. 33.3 minus 22 minutes. 33.3 minutes minus 22 minutes equals 11.3 minutes. 11.3 minutes, all right? 120 degrees minus 57 degrees. Minus 57 degrees. 63 degrees. So I got my LHA, I got my latitude, and I have my declination. Now we can do what? All right, let's enter pub 229. It's all easy now. Now it's just, you got to just pay attention. Pay attention closely. Make sure you have a straight edge, all right? So, what are we going to do with Pub 229? I can close this out, okay? Pub 229. We're going to scroll to my favorite page. I'll scroll to my favorite page, and it's not that far. It's in the front of the book. I fell in love with this page back in 2018 when I took my license. This page is XXIV, all right? XXIV, all right? It's my favorite page, man. And this is the table we need, okay? So let's take this table over to our page and create this table, all right? So we have contrary or same, okay? I'll circle one of those in a second once we figure out. We have the declination. We have latitude. And we have LHA. Now, we have actual arguments. All right. Let me go right here. Let's make my table, okay? So the actual arguments are 63 degrees, 11.3 minutes. That's the LHA. The latitude was 25 degrees, 14 minutes. 14 minutes. And that is south, right? Okay. And then our declination was south, 8 degrees, 30.8 minutes. Okay. And we have our base arguments. And our base arguments are basically the whole numbers. So that's south 8 degrees, that's 25 degrees, and it's 63 degrees. Okay. And contrary or same, our declination and our latitude has the same sign, so it is the same. We're going to X that, okay? In this instance, I'll just erase it, okay? Let's get it out of my way. All righty. So we got the same. All right. Then we have base Z, tab Z, the Z difference, the increments, and corrections. Okay, I hope you guys can see this on the camera good. So the increments are 30.8. That's coming from the declination, right? 30.8 minutes, right? 14.0 minutes and 11.3 minutes. So we have our increments. All right. Now let's go to Pub 229. All right. And we're going to be scrolling. So if we scroll down, let's just go to one page real quick and just see how it's laid out. All right. So we have at the top, you have some degrees, LHA there. You have that's LHA there, right? You have a latitude column here, or a latitude row, right? And its columns. Okay. You have a declination column on both sides, all right? So how this works is, you see how I got the straight edge here? Let me see. This whole line, right? That's 19 declination, okay? this would be 18 degrees, okay? Column. 17 degrees column. All this information in here, all right? So let's scroll to where we need it, okay? So you might ask, hey, LHA is 50, no, what's our LHA? 63 degrees, right? Let's look at our LHA. 63 degrees, all right? And our latitude was 25 degrees. I don't see 25 degrees here. What's up with this? Well, we're on the wrong half of the book. So the first half of the book is for latitudes 15 degrees to 22, all right? So just be cognizant of that, all right? So we're going to go to our side of the book where we're needed, okay? And as you can see, watch, it's going to change. There you go, it's changed, right? So we've changed over, okay? Let's scroll to where we needed it, okay? LHA is 63, huh? As you can see, this says contrary page, right? Contrary, and then on the bottom it has same, but that's a different LHA, all right? And then this one right here is 63 LHA, but it's contrary. So let's look at this page. 63 degrees, right? LHA, okay? Okay, and it's the same, all right? So let's find our, so we know we found our LHA, okay? Now let's find our latitude. Oh, we know it's on the same also. And let's find our latitude, which is 25 degrees. Now, where is our declination? 8 degrees, huh? Okay. And you want to have a straight edge ruler or something, okay? Because these numbers are tiny, okay? And you're going to be in a zone, and you don't want to write down the wrong Z number, okay? You don't want to write down anytime you're dealing with this pub or any pub in general or any type of number, you want to have a straight edge ruler or a piece of paper, something, all right? So you can kind of, just zone in a little bit more, focus a little bit more, all right? You don't want to write the wrong number down, do the whole problem, and then, oh man, I messed up. I got to start all over. Eventually, you'll start realizing, okay, I messed up at this position, but that comes with time, all right? All right. So we're going to get our Z number, okay? Our base Z. Okay? Base Z. Okay? So our base Z is here. Our base Z is here. All right? 94.1. You see the Z column? You see the Z right there? Our base Z is 94.1. So let's write that down. 94.1, 94.1, 94.1. And let me finish up my table. Base Z corrections Z ZN, and I ask myself LHA greater. Okay. Down, over, turn. So let's enter back into the pub 229. And I have my straight edge. So we go down 1, all right? And you see I have it highlighted green. So our base Z was 94.1 right here. And we go down 1 to 93.1. 93.1. Let's write this down. All right, over. So we go back to here and we go over 1, which means we're going over in a higher latitude. This is just triple interpolation, all right? So let's see what we're going to use. Let's try orange. All right, you see that? Okay, 94.7. Turn, LHA. So we turn to a higher LHA. Let's move this out the way for a second. And let's scroll to a higher LHA. Now we got to be mindful that we're still under the same, okay? We're still following same. And I already have it highlighted here, but let's get our straight edge just to be safe, all right? Always get your ruler or something so you can actually dial it in a little bit better, all right? Because it is easy to make a mistake. 93.7. 93.7. All right, now we have the Z difference. All right, so your base Z is higher here than your tab Z for here. So we're going to go 94.1, 94.1 minus, that's the highest number, right? 93.1, 93.1. That equals to 1. So here we have, and we know this one is higher, right? So, and we're subtracting to get to it, okay? That's why it's a minus. This one is a plus because this is higher than this. And if you ever have trouble with the rules, you can always revert back to XXIV table and take a look at that. You'll be right back on track, all right? All right, so 94.7 minus 94.1. 94.7 minus 94.1. 0.6. And then 93.7 is smaller, so I'm going to put this minus here. 94.1 minus 93.7. 0.4. Okay. Z diff times the increments divided by 60 equals correction. 30.8 times -1. 30.8 times 1. That is negative 30.8 divided by 60 equals 0.5, negative 0.5. 14 times 0.6. 14 times 0.6 equals that, minus 60. Okay, plus 0.1. And 11.3 times 0.4. 11.3 times 0.4. That was a negative number, so we was going to be negative, divided by 60. All right. And in this instance right here, we have minus 0.07. We can just round up, all right? Let's make it rounded to make it easy, okay? So it's going to be a negative 0.1, all right? So we're going to total up all our corrections right here. This is total corrections, right? And 0.5 negative plus 0.1 minus 0.1. That's pretty easy, but I'm still going to use the calculator. All right, so we have a 0.5, which is negative, plus 0.1 minus 0.1. 0.5 is our answer for our correction. minus 0.5, okay? So base Z, 94.1 minus 0.5 equals 93.6. 93.6 for our Z. And then right here, LHA greater. I always ask myself that question. Let's go over to the Pub 229 and let's look at our set of rules. Like I told you before, at the top and bottom of pages, you have a set of rules. Here. Here. All right. So in this instance, we have south latitude. So we're going to use this set of rules. And it says LHA greater than 180 degrees, Zn equals 180 degrees minus Z. LHA less than 180 degrees, Zn equals 180 degrees plus Z. All right, so what is our LHA? 63 degrees. Okay, so that puts us in the less than 180 degrees category. All right, and our Zn will equal 180 degrees plus our Z. So we're going to take our Z here and plus 180 degrees. So Zn equals 93.6 plus 180, 273.6. 273.6, all right, degrees. That is our true bearing, okay? Our true azimuth. Now the last thing is G. Here we go. G, right? E, T, V, M, D, C. All right? Let's separate it. Okay. This is plus east minus west, plus west minus east. Okay. And the way I learned this is true virgins make dog companions. My apologies once again. That's how I learned it. I learned it from a sailor, okay? So we're trying to go from our true bearing, 273 degrees, 273.6 degrees, all right, in our PSC, okay? This is our true variation, magnetic deviation compass, okay? Error. This is PGC, okay? So what was given? Our bearing was 266 degrees PSC, and our variation is 6 degrees east. 266 degrees, all right? So we're going to go from here to here, okay? So we see this is east right here, so we're going to take this and subtract it, all right? So 273.6 minus 6 degrees. 273.6 minus 6 degrees equals 267.6. 267.6 degrees. That's my magnetic compass, all right? Now, what is the deviation? We don't have deviation here. So we need to take the difference, which is higher. The 267.6 is higher. So 267.6 minus 266, and we'll find our deviations. 267.6 minus 266, 1.6 degrees. 1.6 degrees. How do I know if it's east or west? Well, we went from here to here, right? And we had to go subtract it, right? So that made this a negative, okay? But we don't put a negative number there. We just put a sign of east, all right? So 1.6 degrees east is our deviation. What was the question? What is the deviation of the standard compass? 1.7 east, all right? Let's take a look at the answer. Oh, there we got it right there. 1.7 east. All right. All right, let me zoom out for you guys to see the whole problem. Hope you guys can see it. Okay. And that's the problem. If this helped you, like, subscribe, comment. More problems, more publications on the way. This is Captain Watson, Anacostia Maritime, and it's been a pleasure. Have a good day.